As the world is transitioning away from fossil fuels, new and renewable alternatives are gaining in popularity. These are usually produced by hydrotreating different feedstocks such as vegetable oil, animal fat or even used cooking oil. Demand in the market is growing rapidly and many companies are considering entering this market. If you are planning to invest in renewable fuels, this video is for you. We will help you and show you how to optimize your processes and maximize your return on your investment. Whether you are planning to co-process in an existing unit, revamp an existing hydrotreater, or even build a completely new greenfield facility. Let's get started. My name is Vivica Laike. I work with Alfa Laval's refinery and renewable fuels customers, helping them optimize their processes. Today, Mike Büttner, my colleague from Alfa Laval US, and I will discuss how smart design choices can help improve sustainability and profitability in plants producing renewable diesel. The production process is called hydrotreatment of vegetable oil, HVO, and it has 4 main stages: feedstock pretreatment, reaction, product fractionation, and wastewater treatment. In addition, there are adjacent processes such as hydrogen production and sulfur recovery. Alfa Laval offers solutions for all these stages that help improve feedstock flexibility, minimize water consumption, reduce OPEX and CAPEX, and cut CO2 emissions. And the earlier we get involved in your project, the better our opportunities to optimize the process using a holistic approach covering the entire HVO complex. Today we will focus on how you can reduce CAPEX, OPEX and CO2 emissions. If you're interested in our solutions for maximum feedstock flexibility or minimum water consumption, please visit our website. Mike, what are your experiences from working with producers of renewable diesel in the US?
Vivica, here in the US, I've been working with renewable diesel and SAF customers for the past 2 years. The big game changer we had here in the US is that through local regulations, carbon now has a value. We talk about a term called carbon intensity, which is really how much CO2 is produced per gallon of fuel. So when I first got into this industry, I approached these customers talking to them about energy efficiency, how we'd help our customers save energy, and help them reduce their carbon intensity score. What I was finding when I was having these conversations was that the customers were interested in carbon intensity reduction, but the problem they were having is that these processes are exothermic, which means that they produce more energy than they needed to put in. So they were looking at using air coolers and product coolers or cooling towers to get rid of this heat. But this type of design philosophy is really outdated. In this world where refineries are rewarded to reduce carbon intensity, a new way of thinking is needed to use this waste heat to help them reduce their carbon intensity score. So working with customers, the refinery industry really needs to look at how do they, number one, design a process so that the heat is integrated properly and it gives the best process design possible. But number two, the real key to this is how do we take this waste heat that typically has gone through air coolers and product coolers and use it within the process. So I have 2 really good examples that I've worked on projects recently where the customers have met that objective about using this waste heat. So the first area that they explored was in the pretreatment process. So this is where customers take oil and they clean it up before they put it into the hydrotreater. There's a number of heat exchangers in this process where they typically use 3 bar or 50 psi steam, and a majority of this energy can be replaced with this waste heat that previously was lost to the environment. The second area where this waste heat can be used is in the wastewater treatment plant, which is at the end of the process. So our customers can use this waste heat to evaporate the wastewater, and this now clean condensate can be recycled to the front end of the unit, which now means that they can reduce their water usage by 90%. So what I think is really interesting about this is that by focusing on the waste heat and trying to free up 50 psi 3 bar steam, it now allows the customers to look at how to use this higher valued energy in working systems like power generation, whether it be ORC or steam, and really have an impact on the carbon intensity score. Or if they have no need for the steam, they can look at reducing the size of auxiliary boilers or maybe the steam methane reformer that was oversized for the process. So for our customers to take advantage of this, they really need to have 2 things. So number one, they need to have a plan or a goal to be able to use this low-grade heat. But number 2, they need to get away from the idea of using shell and tubes, air coolers, and cooling towers, and instead focus using our welded heat exchanger technology to help them reach this objective.
Thank you, Mike. Switching to welded plate heat exchangers can also lead to significant capex savings. Thanks to the compact size and low flooded weight compared to shell and tube solutions, you reduce costs for both heat exchangers and infrastructure when using welded plate heat exchangers. However, the biggest savings are often made on surrounding equipment of different types. For example, maximizing heat recovery in a feed bottom interchanger often makes it possible to reduce the size of the reboiler, or in the case of upgrading the plant, to increase capacity without having to invest in a new reboiler. The same applies to cooling systems in the process. The more energy recovered, the lower the capacity required. For new plants, this means fewer coolers and lower capex, and in existing plants, it makes it possible to increase capacity using available equipment. To round off, we would like to invite you to contact us if you're planning to start producing renewable diesel, sustainable aviation fuel, or any other HVO product. We would be happy to discuss the possibilities in your plant and show you how you can benefit from Alfa Laval's solutions, including pre-treatment, the hydrotreatment processes, hydrogen production, sulfur recovery, and wastewater evaporation. Please visit our website for more information and contact details. Thank you for watching.